Alright, so I think I'm recording. Well, I couldn't find my wireless tablet. Let's take a look at these problems that will be good preparation for an upcoming quiz. Um, One of the most important things that we study, well, the most important thing that we study in this class is functions. So I cut and pasted the definition of a function from your Skill 3 packet. A function is a special type of relation. Remember, a relation is a set of ordered pairs. So in this problem number 1 that we have here, since the members of this set are ordered pairs and x comma a y is typically how we refer to them, this is a relation. So a function is a special type of a relation. A function from a set D to a set R is a rule that assigns to every element in D a unique, meaning exactly one element in R. The set D of all the input values is the domain of the function, and the set R of all the output values is the range of the function. So the input, we typically refer to it as the x coordinates, and the output, the y coordinates. So when we look at this, to determine if it's a function, there should be no repeats of the x coordinates. When we say what is negative 3 related to, there should be exactly one answer. Negative 3 is related to 9. I don't see another negative 3 as an x coordinate. I don't see another negative 2 or a negative 1 or a 0 or 1. At a quick glance here, this appears to be a function. Now, if this list is long, I would probably take the time to do a mapping. I would write the domain, all of the x's, in one container, and all of the y values in another, and I don't have to repeat values. So all of the range is 9. So negative 3 is related to 9, negative 2 is related to 9. So I don't have any repeats, any values of x that are related to more than one y value. It's related to exactly one y value. So that relation is a function. Now here, if we have the relation as a graph, a set of ordered pairs, we have what they call the vertical line test, that if you can find a vertical line that intersects your graph in more than one place, it fails the test and fails to be a function. For this circle over here, you can find a vertical line that intersects the graph more than once. So for this x value of, say, negative 4, you have two y values up here at close to positive 4, and down here at a little bit less than negative 8. You've got the x value that's related to more than one y value. That is not a function. It fails the vertical line test. Now over here, it passes the vertical line test. This negative 6 is related to positive 4 and only positive 4. There's not, for every x, it's related to exactly one y value. That is a function. When we have an equation and they want to say, does this equation define y as a function of x, it might require a little bit more work, or to recall some observations, to recall some shortcuts. Here, I would always start out solving the equation for y. I've got y is equal to negative x squared plus 9. Hopefully you recognize this as a quadratic function, the x squared. This is a parabola that opens downward and has been pushed up 9 units. And this is a function. In fact, it's called a quadratic function, or the squaring function. Now, down here, when I solve this for y, I see that in problem 3 I had an odd exponent. Here on y I have an even exponent. To solve for y, I have to take the square root of both sides. And when we take the square root of a variable, we have to introduce a plus or minus symbol, and that makes it fail to be a function. Because if we plug in, this means this is just shorthand notation for two equations. So they're saying that this equation describes one relationship is that y is equal to the positive square root of 25 minus x squared, and the other, the minus sign, is the negative. So you can see over here, if we plug in 0, 0 squared is 0, and 25 minus 0 is 25, and the principal square root of 25 is 5. And over here, when you plug in 0, you're taking the opposite of that answer we just had, -5. So 0 is related to more than one y value. 0 is related to 5. 0 is also related to -5. Any time that you have an even exponent on y, it's going to introduce that plus minus when you solve for y. It's always going to fail to be a function. So when you see y raised to an even power, you know that it is not, that equation does not define y as a function of x. Here they want us to read the graph. Remember that the function notation is just the y coordinate, that y, we're now looking at y and calling it f evaluated at x. So this is asking me to read off a y coordinate from the graph, but not any y coordinate. It's telling me when x is -7. So here's where x is -7, and the point on the graph has a y coordinate of -6. That's my answer, -6. Now in part B, they've rephrased the question, and there's a typo there. This should have an f of x right there. So f of x equals 0. Well, this is saying provide the x coordinates when y is 0. When y is 0, you haven't gone up or down and you're on the x-axis. So it's in reference to these 2 points, the x-intercepts. X is equal to -1, x is equal to 7. Let's check my answer using the idea that we did in part A. If I evaluate this function at x equals -1, hey, when x is -1, the y coordinate is 0, just like they wanted. And when f is evaluated at 7, f evaluated at x equals 7 is also 0. Okay, so those are my answers there. Recognize that in part A it's asking you for a y coordinate, and in part B it's asking you for x coordinate, which could have multiple. You'll only get exactly one output, but you might have different inputs. Remember, we had everybody going to 9 in that very first problem, and it was a function, you know. All right. So, do I have there? Why do I have a blank page there? I don't know. All right, so here it's giving me a function that it's calling g. Now, again, I have another typo. This should be a g of 12. So I want to evaluate g at 12, which means that everywhere we see an x, we replace it with the number 12. This function g takes the input, puts it in the numerator. So my input is 12. I'll put it in the numerator. And in the denominator, it takes the square root of the input minus 3. My input is 12, so I have 12 minus 3. So 12 minus 3 is 9, and the principal square root of 9 is 3, and 12 divided by 3 is 4. So this g evaluated at 12, it should be a g, is equal to 4. Here it's wanting me to evaluate this function. H takes the input and squares it and then adds 2. This time it's not telling me to evaluate it at a number but at an expression. So whatever we give it, H always does the same thing. It creates an addition problem. It squares the input and then adds 2. So this time the input is a minus 1. When you square a minus 1, it's not a squared minus 1 squared. You have to think of this as a minus 1 times a minus 1. And you need to multiply these two binomials. This is a squared minus 2a plus 1. Don't forget the plus 2. So our final answer, a squared minus 2a plus 3. Because we can combine these two like terms. For multiplying binomials, some people may choose to do it in the form of a table to simply be more organized, and that's fine. You'll get the same answer because along this diagonal, negative a and another negative a is negative 2a. Now here we have a piecewise function. We can't use all these equations at the same time. We have to pick one of them to use. And again, I have a typo. This says h, and over here this should also say h. Well, which equation do I use? Here, this is saying that x is -1. Well, we use the bottom equation. If the value of x is bigger than 4, -1 is not bigger than 4, so I don't use this bottom equation. The top equation will always be an answer of -5, but -1 is not smaller than -2. I'm not going to use the top equation. -1 is between -2 and +4. I'm going to use this equation. Everywhere I see an x, I replace it with -1. And you have to be cautious that -1 squared is +1. So we have 1 minus 2 minus 1, which is just -2, because the +1 and -1 end up canceling each other out. Now here it's asking us to evaluate a function, but it's not giving us the equation to evaluate it. It's saying that there's this, you have these two functions, f and g, and there's some new function, f plus g, and we don't have the expression for that. But it's asking us to evaluate this new function at -2. Well, we can evaluate how it was built, the first function f, we can evaluate it at -2. Then we can evaluate g at -2, and then we can add those results together, and that'd be the same thing if we had found the equation and then plugged in the -2 into this new function. Well, f is pretty simple. It's always an addition problem. It's 2 times the input plus 3. So we replace this f evaluated at -2 is the same thing as -1, because that's -4 plus 3. Well, now we come over and we need to replace g evaluated at -2. Well, what is g? G is always a subtraction problem. 10 minus the input, and this time the input is -2. So we need to simplify this. So our result when we evaluate f at -2 is -1. And here, when we evaluate g at -2, we get a +12. And -1 plus 12 is 11. Now it's asking us to come up with the expression. So we're going to take f of x and add to it g of x, and that's this new function. They could have called it h, but it was kind of nice that they gave it a name f plus g, because it told us how to create the equation. It told us how to create this new function. So f is 2x plus 3. G is 10 minus x. So we just combine like terms. We've got 2x minus 1x is just 1x. And we've got 3 plus 10, which is 13. So this new function is equal to x plus 13, right? All right, now, so here it's not asking me to come up with the function itself, but to come up with the domain. So the domain of this new function, f minus g, is the domain of f intersected with the domain of g. The domain of f, well, whenever we're finding the domain of a function, we always exclude any values that cause division by 0, and we exclude any values that cause us to take an even root of a negative number. I don't have any square roots. I don't have any roots in either one of these equations, but I do have variables in the denominator. These denominators can't be 0. So the domain of f has to throw out -1, because if you try to evaluate this function at -1, you get 1 divided by 0, and that's undefined. The definition of a function, every element in the domain corresponds to a unique, exactly one element in the range. This is not a number, so therefore -1 cannot be in the domain. The same idea applies here for g. The x plus 2, well, -2 and +2 give you 0. So we can't, if you tried to evaluate g at -2, you'd have 1 over 0. So -2 is not related to any y coordinate. There's no output, so therefore this can't be a possible input. We have to remove it from the domain of g. To find the intersection, both of these have to be true at the same time. So I suggest that you draw, when you're intersecting two sets, that you draw 3 number lines. The last number line is going to be our answer. Well, it's going to be a picture of our answer. The numbers of interest here are -2, which is smaller than -1. So I'm going to put those on all 3 of my number lines. And in the first number line, I'm going to look at the domain of f. Well, it was all real numbers except -1. So all of these other values are in the domain. For the domain of G, we excluded -2. But all of these other numbers were in the domain of G. So now for my answer, you have to be a member of both sets to be in my answer. Well, -2 is in the first set, but it's not in the second one. Since it's not in both, it's not in my answer. And the same with -1. It has to be in both to be in the intersection. It's not in both, but values to the left of -2 are in both, so they're in the intersection. The values in between -2 and -1 are in both sets, and to the right of -1 is in both sets, so it's in the intersection. So there's a picture of our answer that we need to describe. The left arrow is shaded, so that's -infinity. We're excluding -2, so we have a parenthesis there. Now, this was the intersection. We had this had to be true and this had to be true. When we're describing our answer, you're in this interval, or you're in this interval, or you're on this part of the number line. So we need unions in our answer. We're never going to have intersections in our answer with the domain, but we do use the idea of intersection to get the answer. And then -1 to infinity. And I ran out of room there, and it's hard to see the blue on blue. So there we go. All right, and the last one, well, it's the same idea that in finding the domain, you can't divide by 0 and you can't take the square root of a negative number. So if we want to find the domain of f plus g, we have to find the domain of f and intersect it with the domain of g. Well, the domain of f, since doesn't have any variables in the denominator, this x plus 10, it can't be negative. It's okay for it to be 0, and it's okay for it to be positive. And if we solve for this, we have to plug in values that are 10 or bigger. Excuse me, -10. -10, if I subtract 10 from each side. So if I have a -10, I need to be larger than -10 in order to take the square root. If I had a number like -11, -11 plus 10 is the square root of -1, and in the set of real numbers, that's undefined. So my domain for f, I've got a picture of it here. I need to now find the domain of g. Well, it's the same idea. This 10 minus x can't be negative. It has to be either 0 or positive. So we need to solve this inequality. When we multiply or divide by a negative value, we have to change the direction of the inequality. And now we're interested in for the domain of g, for values that are less than or equal to 10. Okay. So I put the same numbers in each of my number lines to help me find the intersection, because here's the and part, that you have to be in this set and in this set. You have to be in both sets to be in the intersection. So my final answer, I'm interested in -10 and +10 as my boundaries. To the left of -10 is not here, so, well, let's start with -10. It's shaded in both, so it's going to be shaded in my answer. To the left of -10 is not in the first set, so it has to be in both to be in the answer. Between -10 and +10 is in both, so it's in my answer. To the right of 10 is not in this domain of g, so it's not in the domain of my intersection. So here's a picture of my answer. The domain for f plus g is all real numbers between -10 and +10, including the endpoints. Hope that helps.